Okay, class, we have just completed a couple of limiting reactant calculations to determine the theoretical yield of product, assuming that we had these two amounts of reagents. So another important concept that allows us to evaluate whether a chemical reaction has been successful or to what degree it has been successful is the percent yield. So, the perfect calculated maximum yield that theoretically a chemist might get from a reaction is called the theoretical yield. So the theoretical yield is what we might expect to actually get out of the reaction if everything theoretically went well. Again, it's the smaller of the two values that I get out of my limiting reactant calculations. Now, you've been in the lab and you've run some experiments already, and from your own experience, if a student were to go in the lab and perform this reaction with these starting amounts of each of these reagents, do you think they would always get exactly that amount of product? No, probably not. There's going to be something that happens. There's going to be loss of product because it adhered to glassware, or maybe there was a spill, or maybe there was something else going on in the chemical reaction so that not all of this product could be generated. So there's an important concept that ties into this, and it is called the actual yield. The yield that a chemist actually gets in the laboratory is called the actual yield. And this has a couple of other terms. It's also called the experimental, or another word for experimental is empirical. Yield. So just abbreviated yield, YD there. So the experimental or empirical yield is what you would actually get if you actually went into the laboratory and actually ran the experiment with these amounts. And for the most part, actual yields are somewhere lower than the theoretical yield. Because as I say, something usually happens and we lose some of our product, and so we don't get everything that we theoretically calculated would be possible. Sometimes a student or a chemist might even get more than they theoretically calculated, and that indicates that there's some impurity in the product, so that they are measuring not only the mass of their product, but also the mass of the impurity. My point being is that usually the actual yield is not exactly the same as the theoretical yield that was calculated from the perfect reaction. So to calculate a percent yield, well, it's going to be the same general format as any percent calculation. So we know that the general format for percent is the part over the whole amount times 100, right? So some percent is going to be a part that we're looking at divided by the whole amount times 100. Well, the calculation for percent yield is very similar. It's the part that was actually produced. So percent yield equals the part that was actually produced, which is the actual yield, divided by the whole amount that theoretically could have been produced, that's the theoretical yield, times 100. And that's the percent yield. I want to take a moment here to emphasize percent yield and percent error are two different calculations, and they look very similar, but they are set up slightly differently. So when you calculate a percent yield, make sure that you're not accidentally calculating a percent error. So this is the equation for percent yield. The part that was actually produced divided by the whole amount that theoretically could have been produced. Actual over theoretical times 100. So with that in mind, we're going to do a percent yield calculation. And to save us a little bit of time, rather than giving us a new problem, we're going to use the problem that we ran above. And it says if you were to run the reaction above between the copper metal and the silver nitrate with the reaction amounts given and actually produce 2.7 grams of silver metal, what was the percent yield of the reaction? So let's go back up to this problem where we calculated through stoichiometry the two limiting reactant calculations, and we determined that the theoretical yield of this reaction is 3.2 grams of silver. That's theoretically possible. But in this problem, they're saying, well, what if you ran that reaction but only actually produced 2.7 grams of silver metal? What was the percent yield of the reaction? So if you would please pause the video and go ahead and do that, set that up. And when you're done, restart the video and I'll work through it for you. Okay, coming back to this, we're going to set this problem up. Now, if this problem did not tell me to refer to a previous problem, the problem could have given me a whole new problem to solve for a theoretical yield. And if it had done so, then I would have had to have gone through all of this work just to get a theoretical yield. And then I could plug it into the percent yield calculation. But we're going to make it a little bit easier on ourselves to focus on the percent yield calculation. We're just going to assume that we have just done this problem and we know the theoretical yield of this reaction. So percent yield equals actual yield divided by theoretical yield times 100. Don't forget to multiply it by 100. There's the general form of the equation. And now I'm going to start plugging in numbers. So the actual yield, they told me, was 2.7 grams. 2.7 grams of actual yield of silver. And what was the theoretical yield? Well, fortunately, we've already done all that math, and the theoretical yield was 3.2 grams of silver. Multiplied by 100 equals. And if we do this math, we get 2.7 divided by 3.2. And we resolve that fraction and then multiply it by 100. And I get 84.375%. I need two sig figs though, right? 84.375 rounds to 84%. And that's my percent yield for this problem. So again, what does this mean? It means that if I went into the laboratory and I were going to run this reaction right here, and I started with these amounts of the two reagents, my theoretical possible yield would be 3.2 grams of silver. But then when I actually ran the reaction, I only produced 2.7 grams of silver because of some possible error that was introduced, either a technical error that I made, or maybe a source of error in the design of the experiment. And so I only got 2.7 grams of the silver metal out of it. So what was my percent yield? Well, it was my actual divided by my theoretical times 100. So this 84% says basically I was able to produce 84% of what was possible, what was theoretically possible. And that's how we calculate a percent yield. Again, one last comment. The percent yield and percent error calculation looks very similar, but they are not the same. So be very careful that you're not confusing one for the other.